How are we going to use atomic orbitals to explain the hybridization for iodine tetrafluorine ion? So first of all, by doing this with inspection, we know that the central atom, represented by A, is surrounded by 4 peripheral atoms, and there are 2 lone pairs, 2 non-bonding pairs around iodine. You add up the X and the E, that will give you 4, 5, 6. That means, this number means you will need 6 hybrid orbitals in your, you'll need 6 hybrid orbitals, which means you will need 6 atomic orbitals. So what does this look like in practice? So this is step 1. Step 2 is to draw out a valence electron configuration orbital diagrams for iodine. Iodine has 5s that is filled. Obviously it has a 4d that is filled, but we will not be dealing with any filled orbitals, and besides 4d is not a valence electron anyways because it's all filled. If it were unfilled, then we would consider it as a valence, but it is filled, so we don't care about it. And there's also 5p, which has 3 orbitals that are filled here and 1 that is not filled. So now we need 6 atomic orbitals, right? We need 6. So that means we're going to draw 6 lines. 1 orbital comes from S, 3 comes from P, because there are 3 orbitals in the P sublevel. But now we need 2 more lines where it's not going to come from. So we're going to use the d orbital, but not the 4d. We're going to use the d orbital that comes from the same principal quantum number. We're going to use 5d. And 5d has 5 orbitals that are unoccupied. That means we can attribute these two to 5d, which will give us the hybridization of iodine as sp3d2. Now, because we're drawing the atomic orbitals, we have to also think about, okay, how many electrons am I going to put in here? So first of all, you got 6 atomic orbitals. That means you have to put at least 1 electron in all of them. And then you will look at if there are any non-bonding pairs, any lone pairs, like the balloons I've drawn here. There are 2 lone pairs, so that means we're going to have 2 orbitals that are non-bonding, so these represent non-bonding pairs, non-bonding electron pairs, which means that the 2p and the 2d here are the bonding orbitals, which, as you can see, they are bonded with fluorine. Now, we're not quite finished yet. We got our hybridization, but we also have to make a statement that because we pulled 2d here, that means what's going to remain of the d orbital is going to be 3 empty 5d orbitals. Okay, so there are 3 empty 5d orbitals. Now, if you looked closely enough, you also realize that here we have 2, 4, 5, 6, 7, 8. We have 8 electrons that I've put here. While here I only have 7 electrons. So that means this is fine, it is the way it is. However, that just means you have to make a statement that in order to get from here to here, we also added an electron here. So our hybridization is correct. It is what it has to be, but we just have to make a statement. So to review, we've made a statement that we had to add an extra electron. We got our hybridization, and we also accounted for the empty orbitals that we had to pull from of what remains.